Thank you very much. Good afternoon, everyone. Hopefully no one's too sleepy after lunch. So we're here to talk about our roadmap. We got the clicker. Oh, yeah, there we go. We're over. So, joined on stage today by Josh, our Chief Innovation Officer, and Saiyam, our Field CTO. We've been working really hard over the last year on improving Civo and providing a load of new features for everyone to be working on. So Civo, hopefully those of you know what we do and why we're here, but we are a cloud-native service provider, really focused on making cloud easy, predictable pricing, and really, really super fast launch times. So we believe that this is what the cloud should be, what we should be delivering as any service provider to make your lives easier about developing products and delivering business value for yourselves and for your customers. We really want to get out of the way and let your product shine. And we've got some customers here today, True Foundry, Fermion, and Defense.com. So hopefully you can go out there and talk to them about their use case of Civo and why hopefully they'll give us a glowing review. I hope, anyway. So our main focus is around managed Kubernetes. So we provide a fully certified, CNCF certified distribution of Kubernetes. What that means is that if you've got an application hosted with any of the other providers or locally using something like Rancher Desktop, you can port it to Civo and it will work out of the box with no other changes that you need to do. The launch times, as I said, we've got about 90 seconds to get your cluster up and running. That's also for auto-scaling as well. So in this era where we're looking for cost savings and cost reductions without sacrificing performance, the ability to add nodes and remove nodes to your cluster is really, really important. And the faster we can do that, the cheaper service we can deliver to you, and the more sustainable service that we're able to offer out into the environment. One of the other things I'm really, really proud about is our marketplace. So this allows you a one-click installation or a really simple command line installation of over 100 open source applications. So if you're wandering around the booths or you're looking at the CNCF roadmap and think, wow, this is a really cool tool and I want to play with it, our marketplace allows you to get up and running, again, in that 90 seconds plus application launch time in a cluster that's really safe for you to play around with these applications. If you're a product developer for one of these applications, it's a GitHub repo. You submit a PR, and as long as you do a Helm install, you can get added to this marketplace and get exposed out to all of our users. So really excited for you to try that, give us a feedback on what the install is like, and try these applications, because, again, we want to get out of the way and get these great applications in front of you. One of the other things is security, and we try and give you secure defaults that are there out of the box. So we don't want you fiddling around and making mistakes with configurations. So everything that we do is secure by default following NIST standards. We don't only do Kubernetes. We've also got an S3 compatible object store. We've got managed databases and a really powerful compute engine. Over the past year, we've been working really, really hard on adding GPU support to not only Kubernetes, but our compute engine. And Josh, I know, has got a huge amount to say about what our capabilities are and what we've added over the past year. I think on that, I'm going to hand over to Saiyam to talk about everything else we've been doing.
Yep. All right. So now you know what Civo is, what some of our services are. Let's talk about the next decade. And probably you know where things are going with all the ChatGPT stuff. So it's AI everywhere. And AI is like not only in whatever your tooling you are using as in the developers ecosystem, but when you go shopping, whenever you are booking Airbnb, everywhere, it's just everywhere. But more the AI, more the GPUs which are required, and that means more data centers are required to cater those applications and services. And more DCs, more data centers, means more electricity. But we only have finite resources, and we cannot have infinite resources. So is there an opportunity to innovate over there? And 97% of electricity that goes into the servers comes out as heat. So this is a very interesting point, because the next set of slides are based on this. So I wanted to introduce Deep Green, one of our biggest partners. And Deep Green has a very innovative solution where they reuse the server heat to heat up the swimming pools. I mean, how cool is that? So as you can see, it has the electricity coming in, and the deep green units are installed into that biodegradable mineral oil. And then you have the heat exchangers that transfers the deep green heat into the cold heat exchanger. And at the pool, there is a gas boiler that only when it's needed to heat up the swimming pool, it does it. So that's where it saves like 25.8 tons of carbon emissions and saving the cost as well. So tying into the whole sustainability and cost effectiveness, and also looking at a future where we can develop the AI applications in a sustainable way. And Civo, with Civo, you can create GPUs in the deep green region. So whenever you are creating the applications, the GPU-powered applications on the deep green region, it's sustainable, so you can be happy and creating the AI workloads. The next part that I want to touch on is observability. So whenever we are working with the applications or the set of tooling that we are developing, observability is a key thing that we want out of our applications. And in observability, the key 3 areas are metrics, logs, and traces. And this time we have focused on the logs part of it. So whenever you are writing the application, you would need some sort of logs to filter it out and get the easy logs so that you can debug your applications very faster and you know what is happening inside your applications. So very glad to announce our logging service, which I'll be demoing hopefully live, and we'll see how it works. But overall, this is how the architecture look like. So as a user, when you log in, so you'll be seeing a logging service, and you'll be able to see the different set of logs which are there. And the Civo logging is enabled, and we have a query layer where you will be able to search and add filters on top of that, and you should be able to do that via the API as well. So how it is being done, on every tenant cluster means your cluster, so there'll be a open telemetry collector systemd per node which will be installed, and that pushes out the logs to the Kafka cluster, and then it goes to the ClickHouse cluster, and then it is stored in the Civo object store. So you can see all the powerhouses over there, making sure that our system is able to scale massively and can withstand all the failures. Okay, so demo time. And so I already have a cluster which is logs Austin, and you can see when you are logged in, its logging is already available. So you can click there and you will be able to see the logging dashboard. So this is how the logging dashboard looks like, and you can filter it on various parameters. So I'll zoom in a bit. So you can filter it on the base of cluster name, container name, deployment name, namespace, node name, pod name, howsoever it is, you can filter it by. So let's do that, and let's filter it by the cluster name that we have, logs Austin. So when we run the query, it should be giving us the logs from this particular cluster, which is the logs Austin. And you can see there is nothing much on this particular cluster that is going on, and you can see the timings over there, which matches the timings, current Austin time. So let's deploy some workload. So these are just a random motivational messages that it's logging in to the cluster. Yeah, so the deployment is created. It's running. So let's go back, run the query, and we should be able to see some of the logs from that. And you can see the logs have started to come in. You can expand any of it, and you can parse the body. You can also add additional search. Let's say if you want to search for this particular thing inside any of the pods which are running. So instead of with the filters that you have, you can actually add this particular body sentence over there. So it will search with the filters and the context that you are searching and it will give only those outputs. So that's about login. You can try it out. And the next thing is WebAssembly on Kubernetes. So we talked a bit about WebAssembly in the past. Just to give you a quick recap, WebAssembly defines a portable, size, and load time efficient format and execution models specifically designed to serve as a compilation target for the web. In the waves that we see, how it looks like, so we had the servers. So the next evolution, everyone know, it came the virtual machines, and the next one, the containers, and the next one, obviously, is the WebAssembly. Not obvious, but I feel that it is the next kind of wave in the ecosystem because of how lightweight it is, the zero cold startup times. So WebAssembly kind of fits in the next wave in this computing era. And how it works is, so user writes the code as they usually do. So let's say user has written a Rust code, then they use the similar tooling, which is in Rust, it's Cargo. So they can use Cargo to build the Rust, so build the target as wasm32 wazi, so that it builds .wasm file. So hello.wasm file in this particular case, and that is platform agnostic, that can run on any platform wherever you have the WebAssembly runtime installed. So how you can do it on Kubernetes is with a thing called run wazi shims. So this is a project under container D, which we have also used, which I'll show you. So it's the code that you have written, and then you have the Docker file. You have packaged the application and pushed the OCI artifact to the registry. Then you, on the Kubernetes cluster, you have the run wazi shim, wasm edge, or any other that is there. You create the runtime class and the job, and you should be able to create and run your wasm workloads. So as of today, when you launch a Talos Kubernetes cluster, by default, it comes pre-enabled with the WebAssembly runtime. So you should be able to run WebAssembly workloads on your Talos Kubernetes clusters. And we'll actually see that. So you can see it's just a very simple function. And you can see it's the target wasm32 cargo build, and then copying it, and then the entry point. So let's deploy it. So it has created two things. One is the runtime class, and another one is the job. So that's what it has created, kubectl get pods. And you can see the job has already completed, and we can just see the logs for this. And there you go, hello Austin. So that's where you have successfully been able to run the WebAssembly workload on a Talos Kubernetes cluster. So you can do it as of today. So quickly recapping, you can create a Kubernetes cluster, Talos Kubernetes cluster. You can have your logging enabled and there are 24 hours of log which are already enabled for your particular region, and then that comes with all the clusters, and you can filter by cluster, filter by nodes, and then also add additional context when you are searching for the logs. And the next thing is WebAssembly workloads. So you will be able to run the WebAssembly workloads on Talos Kubernetes clusters by default. It has the wasm edge runtime over there, which is the official run wazi shim. And we'll soon be adding more shims as well, so that you can use different runtimes for your workloads, whatever WebAssembly runtime you want to use. With that, I hand over to Josh.
Thank you very much, Saiyam. And wasn't that a really interesting demo? I think some of these technologies are really coming to the forefront. So I'd like to start out today talking a little bit about an industry-wide perspective of machine learning, and then we'll drill a little bit into what software engineers and developers think about the current state of machine learning. We'll try and meet in the middle between those 2 points. And I think to everyone's shock and awe, the big trend this year is generative AI. But what we're really starting to see is actually these projects getting out of GitHub and getting into big enterprise players' hands. So I think two numbers that come from big consultancies that are really interesting for 2024 is 30% increase in spend on generative AI. That's a huge increase in tech budget. But alongside that, a commitment from KPMG that they're seeing 72% of all their clients start to adopt a generative AI solution in the next 2 years. If you think about mobile, you wouldn't have seen that wave of adoption coming with that type of velocity. I think to drive that even further is we're seeing even wider use cases and applications with multimodality. I think some good examples of that are things like Rabbit AI, a little badge you can wear. As you're walking down the road, it's looking at everything you're seeing to add context to the questions you're asking. And we're getting to these points where multiple senses are being played into, almost like the senses we have as humans. And that in itself is posing societal questions like how do we make sure that generative AI content isn't being mistaken for human content? And the result we're seeing with that is actually a wide degree of regulation and policy coming down. I think GDPR for AI is the first one to hit us alongside it, and then the EU AI Act is very quickly following. And the UK and the US saying this is far too early for us to start making these decisive decisions. And with all this push for AI and adoption, what we're also seeing is the infrastructure underneath being driven alongside it. So actually, AI chipsets have been a huge topic this week. I think we've seen 4 or 5 major news posts in the industry about how these things are really critical to how we're evolving. And most importantly, I think GPUs have evolved from their typical use case of playing video games to accelerating machine learning workloads. And people are pushing those boundaries, starting to ask questions around what chipsets are next. There we go. And this is causing a lot of variation in the market, and then pointing to some of the market share numbers we see around here. NVIDIA own 80% of the current marketplace. And I think the only comparable number we've seen for this before is the early stage of Windows adoption. And people are starting to think differently about these solutions due to these reasons. And what we really think is the way forward is actually how open source, and with all these closed ecosystems that exist and people building open ecosystems to challenge them, I always think both sides win. And this becomes really interesting when you start to think about ownership and how ownership is playing into, can I own my model I run? Do I want to spend some of my R&D budget on building an LLM? Do I just want to give them to a big company and let them worry about that? And what's driving that alongside it seems to be data. There's a huge hesitation from companies to give their really valuable data to companies like OpenAI. And part of the reason for this is data is proprietary. It might be your customer's information. But then also, if I want to go build an LLM, this is my competitive advantage that I put alongside it. And we're seeing this move to quality over quantity. And I think a lot of people are still very wrapped in their minds around LLMs. But if you take the perspectives of the thought leaders in this area right now, they're not telling you that LLMs are here to stay. And they're not telling you that the way that ChatGPT works right now is the way it's going to work next year. I think a good example of this is Sam Altman saying size of LLMs will not matter. And actually the commitment OpenAI have is to build smaller models, less parameters, not more, which is a big paradigm change for machine learning. And then I think Yan LeChun, who's the chief scientific ML scientific officer for Facebook and Meta, has recently been talking about actually how LLMs are just an off-ramp for AI. LLMs are the things we've done as a bit of a stopgap to help show it, and it's almost a consumer benefit for these things. And what happens after this is even more disruptive. And taking all those high-level thoughts and bringing them down to reality about how we sit in front of an IDE or a terminal every day, it becomes really interesting. We ran a machine learning white paper late last year, and we sat down with the community and we asked them the really hard questions about building machine learning, deploying machine learning, and we weren't curt about saying what fails, what wins. And when you start to look at these things, you see that about 25% of the developers who submitted results are realizing that their projects are failing about 50% of the time. And the uncertainty of walking into that room is difficult to go to your CFO and say, I really want to run an AI project, right? And when we start to think about these solutions, we realize that they're not quick fixes. 48% of people who responded to the same survey actually felt that ML projects require too much time. And part of the reason for that is, I think, an individual contributor role that machine learning has to play. But then if you look at the bottom half around team composition, you can kind of realize why the timelines are so complicated. And actually, that 47% of companies building ML products didn't have a machine learning team. And if you think about that, your mobile app development probably sits in its own team. Your software engineers definitely have their own department. And not to say that that's the perfect solution, but 25% of those people also looked at an ensemble team of people with multiple skill sets all working together, and that fits the paradigm like a web development team, a graphic designer, a JavaScript coder, etc. And then 33% tasked these existing complex, almost esoteric jobs to people existingly in the organization who hadn't been trained in machine learning and said, have a go at it. And those aren't unsuccessful, and they're breaking the mold in their own way. And a really interesting part behind this is actually, of surveyed, only 6% of people sat down and had their own organization exclusively for machine learning, with multiple departments challenging safety, deployment. And these numbers, I think, are really interesting because it's how these high-level trends are hitting the ground. And we're really excited that in Q1, we're going to start to release some more of these numbers behind our Civo white paper, so keep an eye out for this on the horizon. With all these concerns that we discussed and the challenges we're facing, we're starting to do machine learning a little bit differently at Civo. And what I really want to drag some attention towards is actually some of our customer case studies, talking about the things that really make machine learning on Civo work are things like our scalable infrastructure, access to high-quality GPUs. NVIDIA A100s is our almost bottom bar. High performance and efficiency, where your clusters launch in 90 seconds. If you're running a machine learning workload and your cluster with an alternative service provider takes 45 minutes to spin up, you're going to be sat there paying for 45 minutes with a compute you're not using. I think some really good points that Saiyam mentioned around we're taking our responsibility of these GPU and high power usage really seriously and providing sustainable solutions. It still blows my mind that right now you can go run a workload on Civo and there's someone swimming in the water that's cooling down your GPU. And obviously cost effectiveness with massive discounts across the board. And just to call out some of our fantastic early adopters and customers like True Foundry and Fermion, who I think really jumped on board with us and pushed through with that, I think I've seen fantastic results that you wouldn't really see with a different service provider. And I remember standing in front of a slide that looked very similar for this in Tampa with much less figures on it, but we're really proud to start to expand some of these GPU offerings and hopefully other solutions alongside that. So in New York City, we're soon to announce H100s and L40S cards in the US region. In London, we've got a really strong selection with A100s, both 40 and 80 gigabytes, but then also launching with L40Ss. L40Ss can have up to 40% increase in performance. With the deep green alternatives on the far right-hand side, which are obviously carbon neutral, what we're looking at is how we also introduce new high-performance chipsets. So these GH200 are Grace Hopper chips. They're extremely rare. You're not going to see these in a lot of other service providers. But we're super excited to actually have in inventory some of the chipsets that can run some of the world's largest models. And I think that as we start to see the future go forward, being able to offer these types of infrastructure are incredibly important to helping you scale. And if you look at some of these pieces of hardware, they're not small bits of kit. It's 144 gigabytes of shared memory. This is one of the fastest chips that you can run a machine learning model on today. And with the growth that we're seeing around this, we think it's really important to have these backed. And we've got some really interesting products that we want to pair with it to make it easy for you to use. With that, I'll hand over to Dinesh. Thank you very much.
Thank you very much, Josh. I think the world is moving towards an AI-accelerated world, and all of the work we've been doing to bring new chips over has been really, really amazing to see, all of the new products we're able to bring to market. But pairing that with the sustainability piece with Deep Green is going to be a real advantage, I think, for everyone running workload on Civo, to know that while you're training models and you're running workload, that you're not going to be contributing to a huge amount of heat being released. I wanted to touch a little bit on what we believe the future of cloud is going to be, and where we want to be challenging this over the next few years. So I think we'll all agree that when cloud started and we started moving workloads to it, we were promised cheap access to compute with nearly limitless resources. And it's something that was going to be very easy to use. And I know if I think back 10 years ago, I feel this is where the industry was. That when we started something up in the cloud and it felt like, wow, it's up, it's running, I don't have any hardware in my data center, and I can just start consuming this. However, I feel over the last 10 years, we might have lost our way, because we're now hearing lots of conversations with customers about how it's very hard to use the cloud, how you're now locked in with a provider that you've chosen. It's very difficult to move out between these. There's a, Ofcom have a report in the UK at the moment about how much competition or less competition there is at the moment in the cloud, and how we can enable people to move workloads seamlessly between providers to get the most benefit for you as customers. So I think vendor lock-in has been a real shift in the industry. Also, I think the cloud has become really complicated. There are more and more options to choose from, that when you go to a list of services, how many people know exactly what they want to use day one, right? You can go, do I need container as a service? Do I need compute? Do I need to run Kubernetes? How about things on the side like databases and the options for all of that? And I think the more choice is great, but it has come at a cost. And I think the more choices that we have had means that it's just really much more difficult to run things. And that comes in hand with what I feel is huge costs in the cloud at the moment. And I think we will all put our hands up here and say that we don't know how much we're going to pay at the end of the month. And it's almost dependent on how successful you are. Suddenly, you'll get a huge cost spike in what you're paying in the cloud. And that's not necessarily related to revenue. I remember the days when you hit the top of Hacker News or the top of Reddit, and suddenly your sites went down that you were hosted on a single server. Now we're in a great position where that doesn't happen. However, at the end of the month, you've now got a 4 times increase in your cloud bill because of all of the egress charges of the data you're sending to serve this. So you're being punished almost for being successful. I think we at Civo don't believe that, and we really want to challenge what the cloud is meant to be. So we see a few trends coming over the next year. Cloud repatriation, we've been talking about for a long time. This is where customers are going to be taking their cloud workload that they've got running and bringing it back into a data center. I know DHH from, what's the company name? 37 Signals has recently done a big project of moving all of his AWS infrastructure back into their own data center. And I think more and more people are going to be doing that. And here at Civo, we want to be powering that with an Edge and Civo Stack Enterprise product. What this is doing is deploying our public cloud stack in your own data center on your own hardware. So as you might be looking to move away from something like VMware, you've got all of this kit there that you're available to use and consume as if it were a public cloud. So all of the services that we're developing, all of the logging platform, being able to move to WebAssembly, you can now run in your own data center. So your developers are still consuming things like the cloud with APIs, with Terraform, but it's local to you. I think that ties in with the last point here about sovereign cloud. I think we're seeing a lot of conversations about countries wanting to move data now into their own borders. There's been a lot of geopolitical things in the world that I don't want to go into, but I think it's really highlighted the fact that people are wanting to have their data locally, and governments are wanting to have more control and visibility of where this important data is. So we'll be looking over the next year to certain markets to start looking at sovereign clouds, which has all of the data stored locally in a single region and allowing customers to deploy that securely. The last area that we're working on in hand with all of this is edge deployments. So as things like GPUs are becoming more and more powerful and powering more workloads, these are being required to move closer and closer to the data that is generating it. So if this is a warehouse with doing a lot of image recognition, and I was talking to a customer that was out in the middle of Austin doing cattle counting. And at the moment, there is someone there with a clipboard and pen going 1, 2, 3, 4 as these cattle come out of a trailer. And they're working at the moment on an image recognition system that is just going to have a camera looking at this herd of cattle, doing object detection to count the cattle. And I think that's going to drive huge efficiency, but it does mean that we're going to be transmitting a whole amount of data from the middle of nowhere in Austin to somewhere in a data center to do this counting. But edge deployments are going to change that paradigm and allow you to deploy GPUs in this backyard in a really secure environment, centrally managed by Civo, to deploy models to allow you to do all of this counting or other model deployments at the edge. I think we're going to see a huge shift over that in the next year. I think what I want to point out, Civo, we're really community-driven. Josh has already mentioned the white paper that we've done, and it's really driving our development roadmap. So as well as having you all here at Navigate and the event that we're going to be doing in Berlin at the end of the year, we're also doing our Navigate locals. So we really want to be staying with communities rather than coming in once and leaving. So we have our Navigate local in Tampa coming up in a few months. So this is a one-day event where we're, again, doing these great talks and trying to give back to the community to not only educate you, but get feedback about how we're doing. The other set of events that we're running is Disruptive Tech. So this is a monthly meeting at the moment in London. We've done a few in India as well. And these are about promoting conversation in the community. It's not branded about Civo. It's about bringing really, really cool tech in front of you so you can learn about it and see what's happening. We've also got our great Slack community that is allowing our users to talk to each other, and we're using to help drive our roadmap. Sustainability is really, really key for us. With obviously Deep Green, we're really excited about it. We're going to be launching more and more regions with Deep Green initially around the UK, bringing more and more flavors of GPUs, and giving back to more and more projects. So the first region is giving back into swimming pools, but district heating is also one of the use cases where we are deploying the heat used into the UK. UK is pretty cold, so all of the heat into homes are being, or sorry, all of that heat is generated is being used in homes. That's really, really important in the UK, and it'll be in the US, is because we're running out of power, as Saiyam mentioned. So being able to use the power to generate heat in GPUs allows us as a community to do some great AI work and still give back that heat to housing projects, which means that we can keep building more and more houses and use the electricity for two uses rather than one. We're really committed to building green data centers, not only with Deep Green, but our other sites as well. So we're going to be continuing to choose sites that are using green power and that are sustainably cooled, and we're going to continue to do that as we grow out into probably into the east. And I'm really excited about the right-size workloads. We want to be ahead of providing sustainable computing, and I think WebAssembly is the future for that. We've seen the ability with Kubernetes to keep packing more and more containers onto a single node. So where historically with a VM, we might have had an Exchange server running at 20% capacity and using things like ballooning to claim those resources back, containers have allowed us to run at 80% workload for that same, 80% usage for that same traditional workload. However, using WebAssembly, I think, is going to be a real change over the next 5 years. And I'm really excited with our Talos offering at the moment that we are able to support that today. Last thing I want to say, I always end with a thank you to the team. We're a pretty lean tech team developing all of this work. Every one of the staff here in a blue jumper are actually Civo staff members. So their day job isn't running around looking after you at events. So they're actually the people that are delivering things like the support services, marketing. We've got developers here as well. So I'm really, really proud that they're able to be here, put on a great event, and show you around. So if you see any of the people around in a blue shirt, they're actual staff members that their day job is making the cloud run. So thank you very much to all of them. So I think we've got 5 minutes for questions.
Okay, Mr. J is very quick with his hand up.
Hi. On your future of cloud, you talked all about repatriation and edge computing, which made me think, oh, are you going to go away from building data centers? Then you got back to talking about expansion of your data centers. So I assume you have some kind of hybrid cloud strategy based on this, with the ability to do as much as you can local or edge and then spilling into your data centers?
Yeah, I think 5G is changing this conversation, right? Because the ability to put compute in the middle of nowhere is changing that. So there is, I think, in my mind, going to be always this split between centralized compute, where you're doing something like training models, is always going to be done in a data center, because that workload doesn't need to be moved around. However, once you've got this image recognition model, the ability to deploy that to the edge in either a low power environment or a really dedicated box of just like a GPU and a small amount of storage is going to make the costs of running things a lot cheaper. So it is definitely going to be a hybrid model, and we're looking to support both. Any other questions? We've got one down here.
Okay, I can tell you. Well, when is the edge clusters coming out?
So the question was about the edge clusters, and so we're looking for customers to partner with at the moment. So like our community-driven roadmap as well, a lot of the features that we're putting out are also driven by use cases. So if there is an opportunity you want to talk about, I'm happy to stay at the end and we can talk about your particular use case. I think we can give. What is log retention? So as of launch today, we're doing 24-hour logs for free for all clusters that are launched. So that is enough to at least do some initial debug. We will be working on a paid tier that will allow for more retention and more customized retention. So over the next 3 months, we'll be working out that and giving it out. But I think it's really, really key at the moment to start with that free offering of the 24 hours retention, so that you can start getting some information out of the systems.
Do you have time?
Yeah.
Do you guys have any plans to launch any products that support more of a managed ML inference?
Josh?
Yeah, it's definitely a thought that we're thinking about. The decision with those types of systems is, do you try and generically support all types of inference endpoints, or do you look at kind of specific models and power those? A good example of that is Recite, which is our speech-to-text engine. That's managed inference there, and that's for a particular use case with a particular model. We also have plans to be able to have that type of generic functionality provided. What you can do today, though, is Kubeflow has our managed Kubeflow offering. You can go directly into that. There's some amazing ways that you can launch models really easily, and actually the power behind Kubeflow lets you serverlessly manage that inference. So if you want to deploy 15 models, you don't have to worry about them all using up idle usage of your cluster, and then when you call it, it brings it into action to infer. I think that's a really powerful pattern. There's a couple of workshops here that we'll be demoing that with. If you want to come along, you'll be really impressed about how simple it is.
I think there's one even by Josh tomorrow, so keep an eye out for that one.
Shameless self-promotion there.
All right, I think that's
Yeah,
about
thank you.
time.
Let's give
Thank
them
you.
a big round of applause.